So, how does eutrophication work? The first step in eutrophication is that fertilizers containing phosphorus and other nutrients essential to plant growth are added to farmland to increase crop yield. After this, rain washes over the farmland, carrying the unused phosphorus and other nutrients essential to plant growth into a nearby body of water. The phosphorus and other nutrients from the farm runoff enter the body of water, creating an unbalanced environment where plant growth is uninhibited. Due to the excess phosphorus from the farm runoff, the algae blooms in massive numbers, consuming the excess phosphorus and sometimes covering the entire surface of the body of water. As the algal bloom consumes the phosphorus levels drop, resulting in some of the algae dying and sinking in the water, where bacteria consume this dead algae and the oxygen in the water. The algae continues to die at an increasing rate as the phosphorus in the water drops. This feeds the bacteria that consumes the dead algae, resulting in a boom in the population of bacteria, and these bacteria remove the oxygen from the water, creating a dead zone that kills the fish and other aquatic life that live in that body of water. Eutrophication results in many consequences not only for our environment, but human activity as well. According to the EPA, nutrient pollution and eutrophication cause nearly $1 billion in tourism losses in the fishing and boating industry, as well as increasing the cost of drinking water from 5 to 10 cents per thousand gallons to over $4 per thousand gallons. To remove the nitrates, almost a 40-fold increase in cost. According to research done by Levia et al., a 2023 study was conducted focusing on the socio-ecological impact of eutrophication in the Chesapeake Bay. The results revealed that eutrophication reduced overall societal welfare and had an impact on overall human health, increasing both mortality and hospitalization rates. According to the University of Maryland Center for Environmental Sciences, eutrophication in the Chesapeake Bay impacted marginalized communities disproportionately, as much of the marginalized and impoverished community in this area is housed on the coast, in close proximity to hazardous zones where these eutrophication events occur. These eutrophication events reduce the quality of drinking water, introduce disease-causing chemicals into the environment, and without the ability to move away, these marginalized communities are forced to deal with the consequences of eutrophication with no real recourse available. Eutrophication is a problem caused by the addition of fertilizers to crops to keep up with the increased demand for food. While this problem is not possible to prevent as a whole, better practices can be adopted within agriculture to reduce the negative impact of eutrophication. Reducing the use of fertilizers would reduce the overall impact, but it would also decrease the yield of crops, requiring additional land to harvest the same yield. What I believe could work to reduce the negative impact of eutrophication is actually the use of eutrophication in a controlled environment. This could be done by constructing canals along the side of agricultural fields that would catch and contain the nutrient-rich agricultural runoff, and allow the natural algae and bacteria to remove the excess nutrients in the water before it is released. If I were a policymaker tasked with addressing eutrophication, I would create an initiative that would address this problem directly at its source. I would create a tax or monetary incentive that would incentivize farmers to construct canals along the side of their agricultural fields. These canals would catch and contain the nutrient-rich agricultural runoff and would allow the natural algae and bacteria to remove the excess nutrients before it's released into the water table or nearby bodies of water. Hope you enjoyed my presentation. Hope you thought it was a little bit interesting, and goodbye.